Assalamu alaikum. Chapter 11, section 1, gases and the pressure. Okay. So what is the pressure as a physical term? Pressure is the force acting normally on unit area. Force is measured in Newton, area is measured in meter square, so the unit of pressure is Newton per meter square, or you can say Pascal, PA for Pascal. And as you see, as the pressure, as the area increases, the pressure decreases. So pressure is inversely proportional to the area. And as the force increases, the pressure increases, force is directly proportional with area. Okay. And then we talk about the atmospheric pressure. This is the Earth, and this is the atmosphere. Okay. If you take unit area of Earth, 1 meter square, there is a column of atmosphere above it. This column of atmosphere that has a distance from the Earth's surface to the end of the atmosphere, for sure it has a weight. And the weight is a force. And this force acting normally on the unit area of the Earth's surface, so this is why it creates a pressure. This pressure is called atmospheric pressure. Now, is there any way to measure the value of this pressure? Yes, using a device called the barometer. So barometer is a device used to measure the atmospheric pressure. It has a very simple idea in which a trough of mercury is used. 1 meter tube filled with mercury is inverted in this tube, in this trough. So we'll have something like this. Okay. This is the mercury surface and the trough. And this is the mercury, the tube was filled with mercury, but when you invert it like this, the scientists noticed that the mercury will fall down till a height of 76 centimeter mercury type. So the scientists said the atmospheric pressure above the liquid in the trough will exert a pressure, right? This pressure equal to the atmospheric pressure. In other words, the mercury in the trough will exert a pressure on the mercury of the tube, also equal to the atmospheric pressure. This pressure can support a column of mercury with height 76 centimeter. So this means as long as you see the mercury column held like this, it doesn't fall. This means that the upward force equal to the downward force. The downward force is its weight, and the upward force is equal to the force that resulted from the atmospheric pressure. So again, the atmosphere make a pressure on the mercury surface in the trough, and then the mercury surface in the trough makes a pressure on the mercury in the tube. The mercury in the tube will hold stationary when the upward force equal to the downward force. The upward force is the weight, and the upward force is because of the atmospheric pressure. So you can have a definition for the atmospheric pressure is that it is the pressure that can support a column of mercury of height 76 centimeter mercury acting on 1 meter square as area. The condition here is the scientists measured this pressure in a certain condition at 0 degrees Celsius and at sea level. So this is why he said that the atmospheric pressure is equivalent to 76 centimeter mercury. Because if you say 76 centimeter, this is unit of length. But 76 centimeter mercury, this is unit of pressure. Okay? If you take the barometer up from the sea level, for sure the weight of the air column above you will decrease, so the atmospheric pressure will decrease, and it can support a smaller I mean column, so the reading will be less than 76. If you take the barometer in a valley, down in a valley, so the atmospheric pressure will increase because the air column above you will increase, so the reading will be more than 76. So 76 centimeter mercury, this is the value of the atmospheric pressure at sea level at 0 Celsius. The units of pressure, we have the SI unit is the Newton per meter square, which you can say Pascal. This is the SI unit. The atmosphere, centimeter mercury, millimeter mercury, or you can call it torr. 1 torr equal 1 millimeter mercury. What is the conversion factor? 1 atmosphere is equal to 1.01 something time 10 to the power of 5 Pascal or Newton per meter square. So I can say it is 101. Okay, it's point, because you can approximate it to 1, but if you want it very, very correct, it will be 1.01, actually 3 to 5. Okay, but if you make it 1.01, it's also right. If you make it 1, it is also right. يعني the difference in the value of the answer will not be that much. Okay. Pascal, I can remove this. I can put this here. See? Okay. Yeah, make it like this. خلاص ما فيش مشكلة. I mean, if you multiply this by 5, by 3, you can make it kilo Pascal. يعني if, yes. Sorry, it doesn't work. Okay, so I can make it 101.325, okay? And then I multiplied here by 100, so I can make it 10 to the power of 3 Pascal. 10 to the power of 3 of 10 to the power of 3 of anything is kilo of this thing, so it can be kilo Pascal. Okay, so either you write it 1.1325 times 10 to the power of 5 Pascal, or you can make it 101. So this means that you multiply by 100. You took 100 from here, so here will stay 10 to the power of 3 Pascal, which you can make it kilo Pascal, because thousandth of anything is the kilo of. Also, 1 atmosphere is equivalent to 76 centimeter mercury, or you can say 760 millimeter mercury. So you can say 760 torr. These are the conversions you need. Okay. Some gases can be collected above water. يعني, for example, this is a conical flask, okay, in which chemical reaction happens and the gas evolves. So I can't take this gas. I want to collect the gas alone. So I can take this gas. And I collect, like hydrogen, for example. Hydrogen does not dissolve in water. Okay, so I can collect it above the water. I can put the test tube like this. Okay, so the bubbles will come up, collected here, and the water goes down. This is called collecting the gas above the water. Here is the gas. Type. And this gas makes a pressure. It's called gas pressure. But here, you don't have the gas alone. Also, some water molecules can evaporate, so this mixture of gas contains the gas itself, like hydrogen, for example, and the water vapor. So the gas here is hydrogen plus water vapor. So the total pressure here, P total, equal the pressure made by the hydrogen and the pressure made by the water, which we call it vapor pressure. So if the total pressure is 80 centimeter mercury, for example, and the pressure of the hydrogen is 75, so this means that the vapor pressure is 5 centimeter mercury. So the bottom line here, that if you have a mixture of gas, so the total pressure made by this mixture equal the summation of the individual pressures made by the individual mixtures, of the individual component of the mixture. And this is all about section 1.